Okay, let's get into it. Welcome to DenverScript. And if you're unfamiliar, I am one of the organizers here. So my name is CJ. We have 3 other organizers, of which Cheddar is here tonight. There he is. Marlene is out. Daniel just had a baby, so he'll be out for a few months. Yeah, congrats to him. Yeah, we have a code of conduct. The full text of it is at denverscript.com/code-of-conduct. I'll give you the abridged version. DenverScript is dedicated to providing a harassment-free community for everyone. Participants violating these rules may be sanctioned or expelled from the community at the discretion of the DenverScript organizers. If you're being harassed, notice that someone else is being harassed, or have any other concerns, please contact a DenverScript organizer immediately. Like I said, that's me and Cheddar. Just let us know. If you don't feel comfortable coming up to us in person, there's Tom. I was worried. If you don't feel comfortable coming up to us in person, you can send us an email, denverscript@gmail.com. In terms of ground rules for the talks, please be kind. Don't talk over the organizers or the speakers. You're doing a great job of that right now. And during Q&A, please ask constructive questions. Don't try to prove a point or a gotcha to the speaker. Save that for one-on-one afterwards. Okay, big thanks to our sponsors. Tonight, I did not pay for the food because,
told them there was a hair in it, we got a refund.
No, Charles at the back there kindly gave a big donation last time, and that went towards the pizza tonight. So shout out to Charles tonight. Yes, yeah. Foods by Charles. Also, the space that we're in is called Code Talent. They are a technical recruiting agency. So if you're a company that is looking to hire people, reach out to them. If you're looking for work, reach out to them as well. And we're always looking for sponsors. Can't just be Charles every time paying for the pizza. So if you or your company wants to sponsor, reach out, denverscript@gmail.com. And we're always looking for speakers as well. I think we maybe have 1 talk lined up for next month, but other than that, the rest of the year is still wide open. So we'd love to hear from all of you. You all have unique experiences. I'm sure that could work very well as a talk, even a lightning talk, like an 8-minute, here's what I learned or here's what I built. So at denverscript.com, there's a form where you can submit your talks. Let's get into the news. So all of these links I'm going to show you is at denverscript.com. Is that how that works? Yeah, denverscript.com. You can find all of the past news links as well. So first in the news, the React Foundation was launched, if you did not hear about this. So React was formerly owned and maintained by Meta, or Facebook, but now it has transitioned to the React Foundation, which is actually by the Linux Foundation. So this is pretty good news. It's not owned by Meta anymore. It's a community project. Of course, there are still people working at Meta that are like a part of the board. I don't know the word. Yeah, like founding members, but also other big companies too. So you've got Amazon, Microsoft, Huawei, Vercel. They all have members on the team. So instead of just being stewarded by one company, now it's more of a community thing, which is pretty cool. In other news, the navigation API is now baseline, newly available. So if you're not familiar with this term baseline, they started using it when they're talking about new features on the web and in JavaScript. And baseline means that all the major browsers, Chrome, Safari, Firefox, maybe Opera, I don't know, the main ones all support these features. And this particular feature is the navigation API. So essentially, you might have, if you've ever tried to do this from scratch, like if you weren't using React Router or something like that, there is window.history.pushState, and it basically allows you to change the URL, what's displayed in the URL without actually changing the page, and that's how a lot of single-page application frameworks work. But that's the old way. The new way has this navigation add event listener navigate. And I do believe there's also some path parsing in there too, because that's another thing that people would typically implement. You'd have to implement like regular expressions to like pull out params and stuff like that. So new API, you might not have to use it directly, but frameworks are probably going to start using it under the hood. It's pretty cool. Who heard about Cloudflare rebuilding Next.js? Yeah, this was a thing. So apparently they spent about $1,000 in tokens and rebuilt the entire Next.js API surface but powered by Vite instead, which is pretty fascinating. And the main idea being, so if you're not familiar, Next.js is built on top of TurboPack, which is Vercel's proprietary bundler thing. I think it's like a Rust implementation of Webpack, but it has never worked with Vite. And what we mean by API service is think of the app router, think of the functions you use like get server-side props, all those things that Next.js provides. They basically re-implemented that, but working on top of Vite instead. So the idea is you could take a Next.js code base, swap out your Next config for a Vite config, and all of a sudden it's working. But not actually. It's like 96% support. Also, a bunch of security vulnerabilities were found, but it was in the news, and it's fun because Cloudflare and Vercel are always beefy. And there was a really good interview on the Syntax podcast. This is where I work. I wasn't on this particular podcast, but this one here, the creator of VNux, the guy that works at Cloudflare, this is like a 40-minute interview. He's just talking about how he did it, which is pretty fascinating because he's actually an engineering manager, and he doesn't really write much code anymore, but he talks about his process of how he was like prompting AI, and yeah, it's pretty fascinating. npmx was released, and this thing is slick. Someone give me an npm package name.
nrel dash.
nrel? How do you spell it?
nrel dash.
Oh, is that where you work?
Branding, yeah.
Oh, nice.
Dash package.
Dash package.
Oh wait, no, it's different.
I see.
It's the bottom one.
It's about, yeah. But you may have noticed as I was typing, these packages are just popping up. So these people, a lot of them from Nux. So Daniel Rose, creator of Nux. I think Matthias, core contributor to Vue. They all got together and made this modern interface for NPM. And so as you can see, as you're typing, it's like giving you results in real time. When you go into a package, nice little skeleton loaders, a really beautiful dark mode by default, lots of cool stats in here. And so this thing is blazing fast. Yeah, if you're looking for a new way to find NPM packages, NPX is pretty slick. And this blog post talks about why they built it and what went into it. In other news, Drizzle ORM joined PlanetScale. So anyone here use Drizzle? It is my preferred ORM. There's a lot of them out there, but it's essentially a way to talk to databases with JavaScript and TypeScript, but it's more of a query builder than it is an ORM. I really like it. But PlanetScale is a company that does like serverless MySQL, and they acquired Drizzle. So it's big news because the team before was just a ragtag group. I think they might have started their own company for Drizzle, but it was all like open source work. But now they're under the umbrella of PlanetScale, which is pretty cool. And then also Vue.js Amsterdam happened, but there's lots of news about Vite as well that happened at Vue.js Amsterdam. So Nux 4.4 was released, Vue 3.6 with Vapor Mode. So I did a talk on Vapor Mode last year. It's essentially a version of Vue.js that can compile to native like browser JavaScript, similar to how with Svelte, there is no Svelte runtime. You write your Svelte code, it compiles down into vanilla JavaScript. Vapor Mode is a new mode in Vue that will basically give you that with Vue, which is pretty cool. But in the Vite ecosystem, a lot of big news. Vite version 8 was released, and this is built on top of Rolldown. So Rolldown is a Rust native implementation of Rollup. So Rollup, you maybe haven't had to touch it yourself, but a lot of bundlers and tools like Vite would use Rollup under the hood. But the Void team re-implemented Rollup in Rust, so it is 10 to 30 times faster. And then now Vite version 8 uses that under the hood. So the short version of it is just install Vite version 8 and everything gets faster. So it's the same API. It's like there might be a few breaking changes, but if you're not doing anything custom, you probably don't have to worry about that. All you got to do is install version 8, and your builds are going to be faster. So that's wonderful news. And they also announced the open sourcing of Vite Plus. So initially, when Vite Plus was announced, it was like this paid-for thing. It was like how Void Zero, which is the company that Evan Yu started, he's the guy that created Vite. Basically, he's trying to make some money off all this open source stuff. But they announced that Vite Plus is now completely open source. And the gist of Vite Plus is they're trying to be a unified tool chain. So you can create a Vite project, you can run check, which automatically runs the formatter, the linter, and type checks. There's like VP build, and the idea being that you migrate your project from Vite to Vite Plus, and you potentially might have to migrate from ESLint to Oxlint, which is their native linter, and then migrate from Prettier to Ox format. But if you do that, you no longer have 10 config files at the root of your project. Now you just use Vite Plus. It handles all the configuration out of the box, and it's fast because it's based on roll down. So they're trying to unify the ecosystem, get rid of this config hell, and make JavaScript fun again. So Vite Plus is pretty cool. I'll talk about it in a second, but Ox format is in beta. This is a Prettier compatible formatter that's native, like 10 to 30 times faster than Prettier and like 2 to 3 times faster than Biome, all from the same Void team. So they're doing cool stuff out there. I'm not going to go through all these resources, but I found some fun stuff that you can check out. This one is really fun. Lyra implemented an x86 CPU in CSS. And it doesn't work in Firefox because it's using some pretty modern features of browsers. I don't want to launch Chrome because I don't know what would open up. But if you look at the source code of the page, it's fascinating. They basically built a compiler that takes a C program and then turns it into a bunch of CSS properties. Like these are like memory registers. And then because modern CSS also supports functions, the compiler generates a bunch of functions. And then modern CSS also supports if statements, so there's conditionals inside of here. But basically, they wrote a compiler that takes a C program, compiles it for an x86 CPU, and then this runs programs that were meant for x86 CPUs in CSS, like with zero JavaScript. It's fascinating. This is a fun one. Has anyone seen this XKCD comic? Yes? It's interactive. Look at this. So yeah, somebody built that. Somebody built Flappy Bird in pure CSS. I left off the word CSS. People are doing a lot of stuff with CSS. And then a couple of articles on people doing various types of migrations. I think for both of these, like in the age of AI, it's making it a whole lot easier to migrate systems. So this team, I think this is from Patreon, migrated 7,000 JavaScript files to TypeScript. This other team migrated from React to Svelte. AI is doing some stuff out there. Now, did it actually work? They say it did, but I'm sure maybe some bugs will pop up. And then VS Code also published a video and a blog post on how they build with AI, so they've got some tips and tricks on like agentic coding and stuff like that. A lot of cool releases. I've talked about a few of these. One to mention, Adonis.js. They call themselves, and people think of them as like the Laravel of JavaScript. They're not super popular. Who here has heard of Adonis.js? Yeah, but they exist, and they're on version 7. But the idea is they're trying to bring a more full-featured framework type experience to the JavaScript world, similar to what you get with like Laravel. But version 7 has a few new features. Check it out. And this one's fun. Knockout.js had its first update in 6 years. So Knockout.js, one of the first JavaScript frameworks in the sense of like data binding and stuff like that. And they're still kicking. So 2 weeks ago, they had a release with some bug fixes, which is pretty fun. I'm out of time. Check out these libraries. React Doctor. You can throw this at your code base, and it tries to find like React bad practices and stuff like that. So it's kind of like a linter, but specific to React. Check it out. And then this person wrote Beautiful Mermaid. If you've ever heard of mermaid diagrams, essentially it's a syntax for drawing all types of diagrams. But this renders them into ASCII or SVG, whereas the typical mermaid render like puts them into a web browser. So pretty cool. Check it out. A bunch of upcoming conferences here. Check those out. That's all I got for now. Anyone want to share some news in the world of JavaScript or World Wide Web? Wonderful. All right, we're gonna get our next speaker set up. Feel free to grab some food and drink, and we'll be back soon.
Woo, thank you. Hi there, my name is William Johnson. It's not necessarily a framework, it's a reporter for Playwright. So the idea is it takes tests that you write for Playwright and then converts that into Markdown so you have a documentation for it, basically. So that's where test-to-doc comes in.
Can I have you use the mic?
Oh, sure. Hey there, how's it going? Can you guys hear me better? Is that better?
Yeah.
All right. For some reason, I thought this was a microphone. All right. So test-to-doc is a fun little reporter I built, just as a quick recap, that turns tests into documentation. So a little bit about myself. Hi there, William. I've been doing the software thing here for about 14 years now. I worked at a handful of little companies you might have heard of. Google, OpenTable, and Remax and Dish. Those last two are actually here in Colorado, so that's fun little factoids. All right, so let's talk about the problem case. So the problem is that creating documentation is a huge pain in the butt. Engineers don't really like doing it, and then it also, because you add new features, congratulations, you now need to write more documentation, or you just accept the fact that, hey, maybe some documentation drift just happens, right? Like that's always a possibility. So, and one of the many downsides of having documents start drifting is that it makes it harder to onboard new people, because it's hard to, if you don't have something to give them, then you just have to actually walk through the code and actually explain it to them. Or you end up actually creating bugs because, congratulations, the documentation, the API contract has changed, and then now the thing doesn't even work the way that you thought it was going to work, so now you have to debug that. So not ideal. So how can we try to solve that? So some people have tried solving that through just like dedicating some time from their sprints to actually create documentation, right? So that is acceptable, but it does slow down development, so it does take away from feature work, which product managers may not necessarily like. Another thing is some people just straight up give up and they just accept that documentation is nice to have, but we don't need it. Instead, they just rely purely on tribal knowledge. So I, myself, have come from a bit of an XP background, which I've tried to advocate everywhere. One thing that helps with trying to distribute tribal knowledge is pair programming, which is not what we're here to talk about today, but I'm a huge fan of it. But what we are here to do is talk about test-driven development. The idea that you actually write your test first, you create your documentation, your contract, and then from there, what's nice is, assuming that you have a nice CI/CD pipeline, you actually are also, it acts as living documentation, acts as a way to safeguard against regressions. It prevents breaking changes, so it's pretty fantastic. I highly recommend people try it if they have not tried it before. So let's go in and do a little bit of demoing here. So I, once upon a time, used to do a live demo of this, but it actually ended up eating up all the time. So instead, I'm just going to walk you through one of the test cases to just show how this works. So let's first show this fun little app I built. So this is a simple to-do app built using Remix and React. So you come over here, you click this fun little button, you say, I don't know, eat more pizza. It's free. So then you add that to your to-do list, and then now, congratulations, you can hit refresh. It's actually saved into a backend, mark it as done, et cetera, et cetera. Not exactly the world's most impressive app, but it gets all the basic CRUD operations. So to document this, we're going to say, hey, we're going to show people how to add a to-do item. So we walk through the steps. We're going to say, hey, you need to click the create button. So we're going to go use Playwright here to go and select it. So we go select the link. We use an accessible name to try to grab it. And then we have this fun thing here called a screenshot, which is a function that's a part of test2doc, which will actually help document it. You can add a little annotation, which adds some meta information, so you can point out things like, for example, the button that we just selected. And then we perform our click operation. So the idea is to try to describe test cases like you would describe how you're actually using the app. So first step is to just click through the thing. Second step is to see that there's a form. And then next step is to actually say, hey, enter in a name for the to-do item. And then we add in a description for the to-do. We click submit, and then we're going to basically just assert that that item has been added to the application. So walking through how to actually seeing this run, come over here, and we have our fun little Playwright interface. Click, and we run the tests, and we see that everything passes like expected, like a live demo should usually work. All right, you got this fun little thing over here to get a little preview of how all the steps, so you can actually walk through how they're all doing it. And then you want to actually go and have this fun command called doc that will go run the tests again, but with the Playwright configuration, so it actually outputs the Markdown. So over here it says that 2 tests have passed and that we've generated 7 screenshots. I hope that's big enough for everybody to see. If not, maybe I just zoom in a little bit more. All right, so we come over, I already started up, and then we come over here, and this is the Docusaurus website. It's literally the most basic template Docusaurus website you can possibly make. Nothing special, but then this is the output from the test. So you can see this is the test that I just showed you before, which is add to new to-do item. So it takes the test name, adds that as the H2 of this documentation, and then it goes through, adds the step block here, and then we have our screenshot, which helps describe what we're doing. And then we're going, hey, look, expects there to be a form. So we have a little form, have a little arrow, highlight everything, and then go enter in a title and a description, and then hit the add button, and then we assert that, hey, look, those things should appear. So it's a nice way to actually document your thing, and you can share this to non-technical stakeholders, which is actually kind of the real reason I built this, is to be able to hand it off to PMs, because, how can I put this? When I ask them to validate that a story is done, they don't actually start up the app and prove that it's done. And so I'm like, well, what if I just give you a documentation that shows it, and you can just go through and review the documentation, and then you actually prove that the thing is working, hopefully as you told me that it should work. And that is basically that on how that works. So the philosophy here is that we want to do test-driven development, write up the test first, because that's going to be your contract on what you expect the thing to do. Run it, it doesn't pass obviously because you haven't implemented it. Then you actually go implement the functionality. Then you have the documentation generated. One of the nice things about this is by using Playwright, we're coming at it from the highest level of abstraction possible. So I feel this is better than unit testing or integration testing. While those are fantastic ways of doing it, this adds for safer refactoring. So the idea is, let's say that we want to move away from React for some reason, or I use Remix to build my to-do app. Maybe we decide that Remix is overkill and we want to switch over to some other routing platform. We can easily swap all that out. And as long as the test passed, we know we didn't break any functionality, everything's working, everything's super happy. And also, one of the nice things about doing things, using selectors, using this get by role is very nice, because you actually are querying the DOM how a screen reader user would actually use it. So you actually get a built-in accessibility at the same time, which is super nice. And just so like you have this accessibility name here, just in case you don't know how this works, because fun fact, this is something I had semi-recently when I started working on this project learned. You can actually go over here, and then you can go into Chrome's DevTools, look at this accessibility panel, and then you actually see the role that it is, in this case it's a link, and also the accessible name. So that gives you a way to target it, so you're very confident, and screen readers also read it like this as well, so that's also super beneficial. And so it's nice to get some free accessibility guidance out of it as well. Some people also use test IDs, and there's no shade against that. I just think that getting some nice accessibility out of it's also much better. Tests become your source of truth, which is very nice. And they become literal living documentation. The idea is when you make changes, congratulations, now you're also confident that the documentation has been changed as well. And the idea is to start moving tests towards describing user flows. To come up with intent is also, I would like to think, a pretty nice happy path. Edge cases are actually much harder to test this way as well, so it's, I don't have a good solution for that. Unit test is probably still good for that. All right. Here's a couple links if you want to check out the actual web app that I built to demo this. It's available at github.com/deathstrobe, React Router to do. If you want to check out the actual website itself, it's test2doc.com. This has all the documentation on how to use the reporter and some nice little quick start guides, as well as I wrote this very long tutorial using Redwood SDK to do TDD for that as well, if you're interested in that. And then you can contact me. My email is wjohnson@nullsweat.io. It's a little company I'm starting to try to prove that this thing works. And I'm also on Blue Sky, the GitHubs, and LinkedIn if you're interested as well. Any questions? Sorry if I talk really fast, by the way. Last time I did demo live, it actually ended up being, I went overtime. So I was like, oh, let's try to speed that up.
Any other question? We'll give you the mic first.
Use the documentation. How do you make Playwright run deterministically in terms of the test order?
You can actually tell it to run synchronously, but usually what you want to do is actually create test data for each test case so they can run them in parallel to speed up execution time. That's what I personally found to be the best way to go about it.
Thank you.
Hi. What about change documentation? Have you thought about?
What do you mean change document? Oh,
Okay.
like a change log. Actually, that is something I need to solve still. Docusaurus does actually support multiple versions, and that's on my roadmap of things I need to support. So I just haven't gone to make it just yet. But that's also something that does need to happen. That does need to happen as well.
2.0.
I was wondering if we could take a look at the code again. So
Sure.
for people that aren't familiar with Playwright, could you kind of point out what is test2doc versus what is Playwright? Because it kind of reads like a Playwright test, but I'm guessing this test.step, that's the test2doc thing?
No, actually, that's native to Playwright. That's one of the beautiful things that why I picked Playwright over other frameworks like Cypress. Cypress has add-ons that can get this step functionality, but I wanted to be really granular to describe exactly what's going on.
Okay.
It does require, you don't necessarily get this for free, right? It's not like some magical thing that's going to perfectly, I actually thought about doing that too. The idea is I would start hijacking all the assertions and just turn that into documentation. But then it ended up, because some things you assert on, you don't actually need for documentation purposes. So I was like, this gets kind of messy. And also there's some weird behavior on trying to hijack some of this stuff that I didn't think was good policy. So that's when I was like, oh, well, let's just make this as manual as possible. So then, yeah, the steps are part of part of Playwright. The only thing that we are executing in here that's part of test2doc is actually the screenshot function. Oh, and also there is it's not in this one. Let me show you another project I'm working on then.
And so I guess you've essentially built a Playwright plugin. They have some hooks you can tap into of when a test is running and what it's doing. That kind of
Yeah, actually, there is some of that. So the idea is when my reporter is running, that's when I want the documentation to get generated. Mm-hmm. So for example, the screenshot function, if it sees that my reporter isn't part of the call stack for Playwright, it's not going to do anything actually. It just basically skips it. But if it sees my thing, then it actually types into Playwright's screenshot functionality, takes a screenshot of the page itself, and then it adds that to this queue where it eventually gets read by the reporter and then gets tossed into the Markdown. So let's see here. Let me show you something more complicated. So I'm creating a scheduling app, and part of test2doc's thing here is in the describe block, I have this thing called with doc meta. This creates metadata for Playwright tests so that you can actually, when you put it in the sidebar, there's a bunch of like extra information that you can do, like positioning it inside of the sidebar position, for example, or add a helpful description, things like that. So I needed a way to transfer that from the test onto the markdown that's generated. So that was my solution, is by creating this function that does that.
Can you show what the Markdown looks like real quick?
Sure. Here we can look at this magical website that I'm currently building. So we come over here, this is the Docusaurus website, we look into the docs, and then so all the Playwright tests that are generated will have test2doc in front of them. And then you can come over here, there's screenshots, and then this is the markdown itself that it gets generated. So here's like a little describe block on how to use stuff, little H1 for the describe block, H2 for the test case, and then it goes and runs through. Each of the step gets its own line, basically, within the markdown.
So you know, a vPress user.
Mm-hmm.
Do you think there's anything in the way that I could use the markdown in a vPress, or is there anything special for Docusaurus right now?
I actually need to look into that. I suspect because it's just markdown, it may actually work with anything that just reads markdown. So
if it's just plain markdown, then yeah, it should work fine.
Yeah. So if you don't use any of like this, what is this called? This metadata stuff.
matter.
Front matter. Thank you. If you're, as long as the front matter stuff's compatible, it should just work. If not, then you could also just like straight up not have any of the with doc meta stuff, and then it just should theoretically just work. So
Cool.
I've been meaning to test it out with other markdown readers and see if it actually works as easily as I hope it would.
A vPress like in the last week, so that's what normally.
Oh,
I don't think I've used it ever before.
okay.
So yeah.
Well, if you're interested in try dog food in this, I'd be happy to help you as well.
Yeah,
So.
I might try it out. I've been building something that I need to build. So I did the kind of reverse way. I started doing documentation and then having that drive the code.
Ah.
Because I'm not a very good test-driven developer.
It's a hard skill.
I tend to iterate a lot while I'm doing things. I don't know the plan ahead of time.
Mm.
Yeah. So. Anyone else? All right. Thank you.
All right. Ooh. That went much faster than I thought. Thank you very much, everyone.
Also, that gradient on the logo was fire.
Oh, thanks. Yeah, I wanted it to be like super, what is it? Like synthwave kind of vibe to it.
Yeah,
so.
but very.
Hey everybody, my name's Tom. I'm a programmer. Tonight I'm going to be giving a presentation on a side project I worked on recently. And before I go ahead and jump in, I just want to do a little bit of, I want to take a little poll and level set a little bit. So who uses AI every day? Show of hands. Okay, pretty strong. Do you guys use like an agent harness, cursor, Claude? All right. I guess the question we ask ourselves these days is how much like trad code are you still finding yourself writing? Like, do you actually still write code, or have you shifted that responsibility entirely to a program? All right, so I kind of want to acknowledge it's a little bit of an interesting time in our industry right now. No one really knows how things are going to shake out. But I think what's clear is that there's definitely been like a step change in capability. And I think the best way you can kind of familiarize yourself with new step change in capabilities is working on a side project. And it's kind of our industry, it's kind of like our responsibility as programmers to keep our skills kind of up to date, and using a side project is a very nice stress-free, low-stakes way of do that. The world is your oyster, and they're free of practical concerns, and sometimes open-ended exploration is the best way to kind of nurture your intuition. And so what makes for a good side project? for me, the point of this side project was basically to test the capabilities of frontier AI labs in agentic programming. I also wanted to test the frontier or the capabilities of open source models running locally on my own hardware. And I also wanted to build something that I previously would not have built, and then kind of as a stretch goal, make something useful that, you know, adds value to my life. And right, that last requirement's kind of a joke, but to be sincere, it's clear that agentic programming is a force multiplier. It's so early and things move so fast, faster than anything I've seen in my career as like a millennial technologist and programmer. And I'm seeing folks, you know, compare the step gap capabilities to like the Industrial Revolution. And so I want to know, like, have you ever had a moment where the agent capability surprised you? And when I'm using a frontier model, sometimes I think to myself, is this how a farmer felt the first time they used a tractor, right? Side project's kind of a bit of a subtext. It kind of doesn't matter. It's just like a theater to like a stage, to a sandbox to play with these ideas. And so this past holiday season was kind of a very interesting time. We had the release of, I think it was 4.5 or 4.6 Sonnet. Gemini 3 landed at the end of November. And it was kind of like a watershed moment for side projects because people had time off during the holidays, and it was like an era of personalized software and bespoke workflows. It's now March, and we've kind of had some time pass since then. And as an industry, we're kind of asking ourselves, like, should we do all this writing of code, right? Like, not can we, but like, should we make a new feature for everything, right? And so it's also kind of given a bit of a rise of a sense of token anxiety. It's clear inference is extremely profitable. Some of the most viral like use cases and examples that we've seen have come from like subsidized token budgets, and that's probably not going to continue forever, right? But at the same time, it doesn't really seem like much has changed in terms of output. Like, everything does not seem to be getting better faster. The opposite kind of feels like that might be happening. You know, teams are struggling at large organizations to deal with these new capabilities. You know, Amazon famously had their AI as be a part of what caused an outage recently. And it kind of feels like, yes, we have tractors, but we have 4 or 5 developers on the same team plowing the same field at the same time with the tractor. So it's like, we're still struggling as an industry to like figure out how to actually remain productive with these new capabilities, and they're changing all the time. All right, so let's go ahead and jump into a demo, and I'll show you the side project that I worked on. So it's a rag app, and so a long time ago, my dad gave myself and siblings a hard drive for Christmas, and it had all of our digitized home video footage growing up. And then so you fast forward to December 2025, and I've had all this footage on Google Drive for a long time, so I just would watch it on Drive with my relatives. So I decided, when I was thinking of AI side projects, home video rag search app was the project idea that I came up with, and so here it is. I'm going to go ahead and type in. Okay, search, and it's going to go ahead and run. And I also built it so it can run in the shell. I'm going to do that while this is going. Show you guys the terminal. It's also a similar app. I can run it in my shell, and I also have logs showing things that the server is seeing. So you can see here's like the query that I ran. I have it running Quen 3 9B parameter for the reasoning and generation model right here. And the later 3.5 Quen models are very verbose in their reasoning, so it kind of takes a long time for it to reason through a response. And it's getting towards the bottom there.
Is this running on that laptop or something else?
I'm actually, it's part of the presentation, but it's running on a computer that I built at my home, tail scale. That's how we're making it happen. So now we're actually generating, we've concluded the reasoning process, we're generating the response, and I have like a strongly typed structures to provide cited sources, and also generated thumbnails. And then I also built like a little video player that you can watch the clip that it found, and it will drag you to the offset in the video that it found the utterance from in the clip, and also play it right there. And so if you saw Halloween clips, there's me, you know, dorking around for being a ninja for Halloween. So that's the demo, and like I said, it runs in the shell. It takes a long time to think. It's still thinking, but it'll spit out the output in the terminal when it's done. That's a little bit of the demo, though. So I'm gonna jump back into how I actually built it. So, do your side projects ever have side projects? And so what's not obvious about the demo that I presented is the entire thing's running locally on a computer sitting in my living room. I call it the Gnarly Box, and the Gnarly theme is just kind of a riff on once upon a time I had a roommate, and we were coming up with names for our Wi-Fi, and we called it Gnarly was in the Wi-Fi name. So that's just been kind of around. And so first I'm going to go over the AI home lab that the entire side project was built on. Then I'll go over an inference server that I built that's running the models. And then a big part of this project was, it's all text-based, none of the reg is multimodal, so I had to transcribe the videos. I used Whisper to do that. And then finally I'll show you guys the actual application, or I'll go into the application, how I built it. So here's a spec sheet for the computer that I built, and I think I built it in 2024 in the summer. Not that expensive, around $2,000. The RAM today costs $500, by the way, so just throw that in there. But when you're kind of building an AI lab off of consumer hardware, you kind of want to max out your PCI lanes that are available on your hard drive, and I could run up to 3 graphics cards on this. I only have 1 running right now, but I wanted to have leg room if I wanted to expand. This is the first time I turned it on. When you're trying to figure out what software to run on this, I was originally just going to run like some type of Linux. I ended up using something called Proxmox, which is a bare metal hypervisor. And all that means is that I can install something on here and then spin up VMs whenever I want, and then I can just like pass hardware. The VMs have access to my graphics card, which is kind of a big deal for, you know, AI. And, you know, having the flexibility of being able to spin up VMs is great if you're like me and you like tinkering and experimenting and configuring and all those fun things. And if you want to run OpenCall, you don't have to buy a Mac Mini. I can just spin up a VM and you're off to the races. So that's a little bit about the AI home lab that was running the demo. When you kind of get into local AI, you kind of have to figure out what your VRAM budget is. So I have an RTX 3090 graphics card that's 24 gigabytes of VRAM. It's relatively GPU poor, but the RTX 3090 is a bit of a legend in the local AI scene. It's one of the best values you can get for $1 per VRAM. And so when you're allocating budget, you have to factor in the precision of the model that you're trying to run. You also have to reserve room for your context window, which is called a KV cache, and just overhead for whatever inference engine that you're running. And so behind AI, the main operation is just matrix multiplication, but it's like a whole lot of matrix multiplication, like an unfathomable amount of matrix multiplication. So much so that the bandwidth, the bottleneck is memory bandwidth, not CPU, like the time it takes for you to like actually perform the calculations. So like a model like GPT-3 has 175 billion parameters, and those are just numbers. And you know, it's a computer. We have to represent numbers as a way, but you can basically just think of it as you're having to perform a calculation with 175 billion like factors to a calculation. You have to perform a lot, right? I'm gonna go on to a concept called quantization. And so in JavaScript, we represent numbers in 64-bit floating precision. Most AI models represent their numbers in 32 or 16-bit precision. That's like the native format. but you can actually, to shrink the size of the models, you can do what's called quantization, which is basically you're just representing the same model, the same numbers in a lower precision. FP8 or INT4 are two like very popular quantizations when you're trying to just like shrink your model size. And so yeah, factor in mind like you're running a calculation, it has gigabytes worth of things to factor in. If you have them all in your GPU at the same time, being able to run on thousands of tensor cores in parallel, that's what makes GPUs performant for AI. They have high memory bandwidth. It's not so much like you could technically run models on your you could store the model weights in your RAM and run your calculations on your CPU. That would take like 10 to 50 times as long though to actually do the same thing. It's also why like Apple is a really good platform for running local AI because the way they architected their chips, it's a lot of memory that's available. So this is a JavaScript meetup. I want to touch on KV cache real quick. You can kind of think of KV cache as use memo in React, where the point of use memo in React is that it will cache previously calculated values for whatever you're rendering if you have a complex value. So imagine you're trying to cache like a dynamic list in a front-end component with use memo. Every time that list gets added to, you don't have to go over the entire list and calculate it. It will cache previous calculations, and you just really need to calculate the last one. That's pretty much what you get with a KV cache when you're running inference on a computer. And then one thing to kind of to take into mind is that if you did not have a KV cache, your memory footprint would scale linearly with the size of your input, so it would just keep getting slower as the tokens grow. And your KV cache also has to take into account not just your prompt, but the response that it's being generated. So if you have like this 8K context window and a 6K prompt, you only have 2K left for generation. So I just want to do a little bit of a primer on Reg before we jump into some of the actual components of the side project. So Reg is in its simplest form just vector search plus generation, and the generation is what you use a chat model for. The vector search, you can usually run an embedding model, and you can even run those on your CPU. Reg's not new; it's been around for quite some time now. There's been a lot of optimizations to improve the accuracy of Reg beyond just vector search and generation, but it pretty much all just boils down to using more inference during the retrieval process or after the retrieval process. So like instead of just like passing your query straight to your embeddings, you could have an LLM rephrase the query that like closer matches your database schema and then run the query. Or you could perhaps generate 3 or 4 permutations of the question and then run all those and sample from all of the responses. You can post-retrieval after you've gotten documents back from the model, use another LLM to re-rank them neurally. And so I actually ended up using a neural re-ranker in my project that I just demoed, and I kind of wanted to mention it because those are the inference constraints that I had in place for this side project. And I've built, this isn't the first thing that I've built on this AI home lab that I've built. In fact, I've given presentations here on other AI side projects that I've built here. And I've previously mostly just used Ollama, which is great. And I recommend it if you're getting started with AI. It's very easy to get up and running. But for the app that I'm trying to build here, I needed to run several models at the same time, like I was mentioning, and then a lot of the value that Ollama provides is just like a model catalog that's easily to pull from, but once you're kind of like committed to, like there were not embedding models that I wanted to use on Ollama, so once you're kind of committed to getting out of, to like using Hugging Face directly, Ollama really doesn't have that much value. So I ended up using vLLM for this project, and that's pretty much what folks use for production use cases when they're running inference servers. I used the container version of vLLM. You can install it directly. Because I'm running 3 different models for this, so I'm running a generation model, an embed model, and a neural re-ranking model. And so I'm constantly having to like spin up programs on the shell, and it kind of got really cumbersome. So the first thing that I kind of spent some time working on in the project was something that I called gnarly vLLM, which is just like a container orchestrator that I built that was pretty much just to smooth the UX of spinning up all these different servers. So what it would allow me to do is basically this. Like it specifies a format in TOML, and all of those flags that you see pretty much just get passed through to the underlying program that gets called. I wrote some code that like parses, well, I didn't write the code, my clinker wrote the code, that parses this TOML file into basically like a TypeScript object and then orchestrates spinning up all the different containers. I wanted a config format that would allow me to run the same model with different parameters and then name them. And so the syntax that I came up with allows me to like override them. And then also I came up with this concept called a stack, which is basically a set of models all configured together. And that's what you're seeing on the right side there. Is basically like when I'm actually running the search application, I need to spin up 3 different models and then I won't configure them the same. Like, but the 2 big use cases for this were a big model during the ingestion process where I can dedicate all of my VRAM to one model, like Quen 27B 3.5. And then during the search app, I can't do all that, so I would pretty much tune the GPU utilization feature to split it up over 3 different models, and then I have that configured in this TOML file, and then all of this is exposed through a CLI that I run, and so I'll just say, start the name of the server, and it will start it, or start the name of the stack, and it will start all 3 of them in sequence, and then if you guys came to the meetup last month, there was a presentation on Bun Mono repo, Bun workspaces. It was pretty cool. But anyway, I mentioned it just because I also used Bun spawn in here to execute these shell commands that are running the vLLM instances underneath the hood. On top of that, so I didn't want my client application to like have to talk to all these different servers or really know that that's happening. So I built like a proxy server that stands in front of it. And it's funny, I actually first implementation was Light LLM. I don't know if you guys heard, they fell victim, unfortunately, to a supply chain attack today, and they had to freeze their releases on whatever you use to manage releases in Python, like pip or whatever. But when I shipped 3.5 Quen on this, I was dealing with like teething problems. There's a lot of teething problems when you're like on the bleeding edge of running AI. It kind of reminds me of front-end development. There's a lot of churn. But anyway, I ended up rolling my own proxy server that I call the gnarly proxy. That's just like a button server, and it handles proxying to the underlying servers that are running, and that way my client application just has like a single entry point. This is also where I first experimented with building TUI applications for it. So if you've ever used OpenCode, there's a library that powers OpenCode called OpenTUI. I built this dashboard that shows, I could like start stacks or not in this dashboard. I really don't use the dashboard that much. I use the CLI more, but I did end up building TUIs to help my ingestion pipeline for this application. So that's a little bit of the inference servers. Next, we'll go over the project that uses Whisper to transcribe the models. So this is the thing I probably spent the least amount of time on the project. I already had, like I said, 150 gigabytes of home videos on Google Drive. At first, I tried to make this really fancy sliding window downloading approach that would just download I would set a 10 gigabyte buffer window size, and then download a video, transcribe it, produce the artifacts, and then go on to the next one. But I ended up bailing on that and just increased the hard disk size for my VM that I was running on. But basically, I was able to spin up a pipeline that transcribed my Google Drive videos for Whisper. I spent some time optimizing it. Turns out the best way to do that is to use 16 kilohertz audio files. I was able to use Whisper Large v3 to do it. The output of this process spits out VTT files, SRT files, and this JSON file that has word level transcripts. And I kind of spent some time iterating on a pipeline that I could break each kind of process down into the pipe, break each process down into a set of atomic operations that I can run by themselves or in a batch. And this is what one of the generated JSON transcripts file kind of looks like. You can see there's word level transcripts, word level timestamps in the transcripts. All right, so that was the project that I used to transcribe the 150 gigabytes of videos. Now let's get into the actual application that I demoed. High-level overview of the features that you saw. So it implements something called hybrid search. In addition to searching the embeddings, it also does a full-text search using something called BM25. Saw the inline video player. Thumbnails for the search results. I used FFmpeg to generate the thumbnails, and I did it in the same Whisper project as well. There's search results, grounding, citations. Kind of went overboard. I wrote a strongly typed MD-JSON schema for streaming to the client, and it was kind of worth doing that because with this strongly typed schema that streams to the clients, I have the clients can consume this schema and implement however they want. So I can run it in the shell, I can run it in the browser, and it's the same schema for both. Here's a little bit over the stack and the architecture. It's just a Bun mono repo organized into a bunch of different packages. I use Bun, SQLite, AI SDK from Versal, Drizzle, and Zod. This next slide kind of useless because I don't know how high resolution that is. Yeah, but this is the data model. Basically, I have a videos table where we store most of the videos metadata and also the entire generated summary of the entire video. The video, I ended up, there's a bunch of different ways to tweak like your ingestion pipeline to figure out the best way to like chunk your data when you're doing reg. And I ended up doing something where I split the video up into a series of chunks that are about 2 minutes long. And those are in this, I guess I'm not even gonna like try and present this slide. That's my data model. So the ingestion pipeline is about like a 6 or 7 or 8 step process depending upon if I do some of the optional extractions that I've kind of tinkered around with. But it pretty much just starts off with an adaptive chunking process where I slice up the transcript into those like 2-minute segments, but it's not just 2 minutes, there's a 15-second overlap. Plus I wrote some code in there that tries to find like natural pauses or sentence ends to split up, so it's not just like abruptly cutting up a sentence in half. After that, I've got my videos broken down into a series of chunks. Then I use an LLM to summarize those chunks. Once those chunks have been summarized, I also use an LLM to perform entity extraction, where I'm trying to like look at the transcripts and optionally the summarized chunks and say like, was there a location in there? Was there a person in there? And then as this is happening, as the entities are being extracted from the summarized chunks and the summaries are being generated, they're all being persisted in the database after that happens. After the extraction process, it generates a lot of noise. There's an entity-based clustering process that tries to create canonical representations of all the entities that have been extracted from the transcripts and the summaries. And then the last 2 steps are pretty much just like, so there's like a materialization process that creates virtual tables to increase the search times. And then the last thing is I have to run an embedding model, and I embed the generated all of the generated summaries and entities and all this stuff into the database. So I start with raw transcripts and I end with like a database with like entities inside of it and all the transcripts and everything. So yeah, we have seeding and the adaptive chunking. I kind of just described a little bit. Here's the actual prompt that runs when I'm running the summarization pipeline. And you can see it's pretty straightforward. Just asks it to describe the prompt, what it's seeing in the transcript. I ask it to return structured object, just a title and a description, I believe. Summary. Here's the prompt that I use to generate the global summaries. Very similar process, but this one I've flattened out the chunks for an individual video. All the individual scene summaries are rolled up into one and passed in one prompt, and asked it to generate the global summary of the video. Here's a little bit of the entity extraction prompt. This one's a little bit harder to read. Maybe I can. That's not, oh boy. Oh wow, look at that. It's not even, I don't know how they have the technology to do that, but they do. So yeah, it's basically just a fancy prompt. Uses a lot of reasoning tokens. It's asking for structured output, and it's giving me this JSON. I put in the prompt a few shot examples of what the response should look like, and it's just another structured output. And so like when this is running, I'm persisting the entities into my database. I mentioned we have a clustering and canonization process. Here's the prompt for entity clustering. I have 3 different types of entities. I have participants, locations, and events. So the materialization step just joins all the query, makes the query sufficient. The last thing is the vector embedding, and here's what we're actually embedding into the database. You can see I have the title and the summary from each chunk. I have the actual transcript itself. So just all the stuff I generated stick together. That gets embedded into the database. And so earlier when I was describing the Whisper process, I mentioned how I kind of like to do things like in an atomic way, and then such that I can run them one after the other on a small sample size, and then tweak settings and then tune them, but also be able to run them once the churn has settled, be able to run the entire extraction pipeline. And it takes a long time running it on my local machine, but my first approach using just like global summaries was very slow. The consequence of breaking it up into chunks meant that I could actually kind of plan ahead of time what the work was going to be and parallelize it. So I had like a parallel, I basically could have I basically would set up like sessions where I would tinker with the parallelization settings and then configure with vLLM how many, you can configure in vLLM how many requests you want it to handle. And so if you think about it, it's a production inference server, you're serving multiple users. Concurrency is kind of a big part of using vLLM. So I was able to tune my throughput, and because I'm using chunks, I'm not summarizing videos one after a time. I'm summarizing all chunks across all the videos in an order that makes sense, and then I'm also interleaving in between videos, and I have like a pool of workers that are available, and that's set to the same amount of concurrency that I'm running on my vLLM. So say I have 24 different workers running, I can at most be processing 24 different scene chunks at the same time. And then this was much faster than my first approach. And for like running like at the edge of my inference limits like a 4-bit quantization of the 27B param 3.5 Quen model would take like 12 hours to do this, plus the entity extraction and all the other things. So that's the ingest pipeline. So all that work just to get your data in a good spot for retrieval. And the retrieval process that I ended up with looks like this. It's 5-step. First step, we try to detect entities in the query just by like using regex, and then we select them, and then we do a concurrent candidate search, which is basically we search our vector embeddings at the same time as we do our full text search. When that's done, we're going to get back 40 documents from that candidate process. I use something called reciprocal ranked fusion to re-rank those 40 into 10 documents. Once I have those 10 documents, I send them to my neural re-ranker. That uses a cross-encoding model to re-rank those, to not change the amount, but to reorder them. And then after that, I do something called post-re-rank boosting to narrow down the set of documents from 10 to 5. And then that's what I pass to the LLM in the system prompt as context in this. So like this is an example of what the context looks like that I'm gathering from retrieval and passing to the model. And this is the actual system prompt that was running in the reg app that I'm running. And you can see we just basically say, hey, I'm handing you a bunch of information, like cite your sources. That's the system prompt. After the generation phase has happened, I kind of parse the response into the ND JSON schema that I mentioned. And I previously would use like use chat from AI SDK for this, but in my UI, it's just like single shot search. There isn't like a chat history and everything like that. And a lot of the functionality that you get from use chat is for like multi-turn apps. And I was just like experiencing some teething issues with trying to like use it. So I ended up like, I guess like coming up with this NDJSON schema that I'm showing. This is a little bit closer look at the actual schema as well. And what's nice is I implemented with Zod, and each client can kind of use this information and render it however they want. And basically, during the reg process, I wanted to use the reasoning phase as basically, so like if you have a model that has reasoning, you can see its reasoning tokens. I wanted to basically use that as a pending state for the UI. That was part of the reason why I wanted to create my own JSON NDJSON schema. I packaged up all of like the application logic into a class called the Family Archivist class. It has access to all the models in the database, and basically it implements this method called query that returns a generator. And that's pretty much how I implemented streaming. And so in the server, you can instantiate this class and pass the generator to an HTTP stream and stream it down to the client. In the client, you just loop over it, or in the CLI, you can consume the same generator just in your shell and loop over it. So that's how I'm using it inside of both of the platforms. You guys saw the features of the app. Oops. Yeah, I guess one of the cool features was like after I had the chunks generated, I was able to use the chunk bound offsets for my thumbnail generation. So I just had a script that was like, hey, you have access to my database. Grab each chunk has a start and an end, just grab the middle point of that and then select a screenshot. And then with FFmpeg, it's really easy to just like do, it took like 3 seconds. But that's pretty much the app. I built it all with AI and kind of got some opinions on it. And like I said, I wanted to test what you can build with AI, both locally and using agentic programming. Turns out you can build pretty powerful experiences with low parameter count models. That's, I guess, kind of hopeful. Agentic programming still has a long way to go before you're able to like run Claude Sonnet locally. But we're getting there. My timelines keep accelerating, to be honest. A little bit about my development setup. I basically just have a dedicated VM on my computer, my Proxmox hypervisor. I'm a very heavy shell user, and so that's part of the reason why I was like, I'll just install a hypervisor. It's not even plugged into a monitor. There's a little bit of like, inconveniences when you're trying to run like a server on your shell, but you're like on your laptop trying to interact with the UI. You can get around that with SSH port forwarding. But it's also on the flip side really nice to have an always on server like at your home. I can close my laptop, I can walk away. On my phone, I have an SSH client that I can log into the server, and then I'll turn on OpenCode Web, and then I'll use the web interface of OpenCode through my mobile device and just use my Android microphone to like just dictate. So it's a pretty interesting workflow. I'm starting to ramble. I'm probably over time, so I should just end it. Thanks for letting me demo the app that I built.
Questions? Questions? Yeah.
Out of curiosity, have you been able to try to use any coding agents and run those locally, and then you just like, hey, congratulations, now I don't have to pay Claude for tokens or whatever anymore?
No, not yet. I mean, you can watch CJ has a really cool video on your YouTube, right? Yeah, where you were running Qwen 3 Coder on a Strix Halo setup.
Yeah, Qwen 3 Coder, and then Qwen 3.5. They don't have a coder model yet, but Qwen 3.5 still is pretty decent. But youtube.com/syntaxfm. they're not great. I mean, it feels like coding with AI a year ago or 2 years ago.
Is that because those are the open source models and they just haven't caught up yet?
I would say because of the parameter sizes that you're able to run locally.
Okay.
So I have a machine that has 128 gigabytes of unified memory, and Quinn 3.5, the 30 billion parameter model, takes up about 30 gigs of RAM. And so like that's just over the limit. Like he has a 24 gigabyte one. You can barely run that one. So yeah, it's really the model sizes, because there's Kimi K2.5, I think is the one. Is that the one with the trillion parameter? Yeah, they have a trillion parameter model, but you would need like terabytes of RAM to be able to run it. So it really just comes down to how much VRAM can you have in your home to try to run some of the bigger models.
Questions?
With the running like the coding models, did you, or even like your model, did you ever try setting up like a VPS and like using more resources there? Did you notice if it would be cheaper to do that than like just paying for tokens?
I've never self-hosted on a VPS, only on my local setup. But I have explored, I guess now that I'm getting into like running production inference with like vLLM, the thought had crossed my mind to run like a full like H100 set or something like that. But yeah, I mean, part of it is to test what you can do at home, and I guess that kind of defeats the point. But it is nice, I guess, like to have complete control over running a remote VPS. But yeah, so no, I haven't, but it's crossed my mind.
Yeah, so I'm just getting into trying to run some AI agents locally. I saw when you broke it down into a stack, and then you had the GPU usage, and then there was a decimal. Was that because you're running multiple concurrent agents, and then you're giving them a percentage of 100?
Yeah, so there's a feature you can set on vLLM called GPU utilization, and it will kind of like, so vLLM is going to try and max out all of your memory, and it will allocate all available VRAM that you have to KV cache. Even if, so say I'm only setting like a 6,000 token context window, and I'm running like a 7B model. I have a lot of space left on my GPU. vLLM's gonna try to allocate all of that to KV cache. And you can kind of tamp that down by setting the GPU utilization feature to say don't, just leave some VRAM available. And so in the stack configuration, I have to split that up over the 3 different models that have availability, and I'll pretty much just bias it towards the generation model, because the other 2 models have a very low param count.
Gotcha, interesting. And then what, was it just playing around with it that you figured out what models worked best for your stack? I know you said that one of them was ranking and you had several others. Was that just you poking around with it to figure that out, or did you see some obvious pattern of what models work best for one?
I would let the agent drive. Honestly, I have NVTop installed on my system, which gives you GPU memory usage information, and then Podman for my container solution. And then I mentioned how I spent a lot of time making it so the program would run in the shell, and that was by design. So I could just have the agent run the search query, and then I would say, okay, run this query, tail the Podman logs, and look at my GPU. Am I properly saturated? And then I would just have it turn the knobs until it, and I did that to tune my prompts. I did that to tune my GPU utilization flags and all of the parameters for my inference server. But yeah.
Very interesting.
So you have Proxmox at the top of the hypervisor, you get a VM running on SUMI Linux, and then pod running inside of that. Do you try LC containers to basically eliminate the middleman?
What about them?
So with Proxmox, you run either VM or an LXC container.
Yep.
So would it be possible to run that as an LXC container? Did you actually try that? I'm not quite sure you get GPU utilization of the pass-through on the container, but that might be something to consider.
No, that's a good point. No, I didn't. There's a really popular YouTuber though who tests out, like, I remember he ran DeepSeek on a like 153090 setup, and he installs OpenWebUI and NVIDIA CUDA on the Proxmox container and runs it through LXC, like you're saying. I never got it before. Like at first I was not even considering bare metal hypervisor, I was just going to install an operating system directly. I haven't noticed performance hit at all, GPU pass through or anything like that.
You're about 10% on Fox models from that scene, but I mean, yeah, I guess figured like the next level, want to squeeze the apps and actual performance, that'd be the way to go. It's 10%. Nice.
I'm really curious about your chunking strategy. So I'm working on a RAG app right now, and the only like in learning about chunking, can you pull up your chunking slide? Because you have like all these different types of chunking, and so like you could build an app where you just do one version of chunking. Like let's say you have a 10-page document, you split it up into chunks of like 2,000 tokens, and then each one of those gets vectorized. But like your pipeline, you've got chunks, and you've got summary, and then you've also got like entity extraction. So it's really cool. I guess I'm just curious, like, how'd you come up with it? Is there other resources for like better ways of like chunking your data and making it more searchable, I guess?
It's $1 million question. Another thing that I kind of let the agents kind of tune a little bit. I started with a super naive approach with no chunking, just each transcript. And I did some time calculating max token size for my largest. So some of the videos are like 3 hours long. It's like 12,000 tokens for the largest video. But as you know, chunking, like it's a bit of a Goldilocks zone to try to find like the size of your chunk. And then I didn't spend any time trying to like semantically chunk. I wrote an algorithm that mostly just looked at the bounds of the timestamps around the words to split them up into 2-minute windows. And that was a pretty naive approach, and it actually worked pretty well. I have an eval suite that I run. So every time I would change something core like that, I would rerun the eval suite, and I have like 2 or 3 different videos that I would re-embed and rerun through the entire extraction pipeline with the new tunes, and then see if it would work. And then also I have to factor in like the parallelization.
Cool. I have another one for us. Okay. So you mentioned you're using SQLite. Which vector plugin did you use?
SQLite Vec.
Okay. Because there's like 2 of them. One of them, like, is that the more modern one or the one that's more up to date? Or
I don't know.
okay.
Yeah.
Yeah, it's just. I
It
mean,
works with Drizzle. I'm using Drizzle.
Yeah, and that's one of the things I'm trying to figure out too, because like you can use SQLite, and there's a SQLite add-on, but then there's also libSQL, which is a re-implementation of SQLite, and they have vectors native to them without now. So yeah, I haven't even settled on what database I'm going to use, so just curious.
I'll put this in the meetup thread.
Cool. All right, thanks.